module, we're talking about empirical formulas, what they are and how to find them. So an empirical formula is just the smallest whole number ratio of the elements in a compound. Now, the true or the molecular formula is always going to be some integral multiple of the empirical formula. What do I mean? Well, these are two molecular formulas. This is acetylene, this is benzene. Both of these have the same empirical formula. In acetylene, the smallest ratio of the numbers of elements, carbon to hydrogen, is 2/2, which is 1:1. And in benzene, it's also 1:1. So that's what empirical and true formulas are. Now, we can calculate the empirical formula if we know the mass percent composition. And you know what a mass percent composition is now. For example, let's say that we have a phosphorus of, an oxide of phosphorus. That means it just contains phosphorus and oxygen. And it's this percent phosphorus and this percent oxygen by mass. We can calculate its empirical formula. The reason why this is an important calculation is that experimentally, a lot of times we can find the mass percent composition of a compound without knowing anything else about it. And then once we know that, this calculation lets us get the empirical formula. And you'll see in the next module, once we know the empirical formula, we can find the molecular formula. So, this is the procedure for finding the empirical formula if you know the mass percent composition. First step is real easy. The percents that you have, just convert them, just make them into grams. We know, okay, the mass percent composition is a conversion factor. There's this many grams of phosphorus and 100 grams of the compound. Well, what we're doing is we're assuming we have exactly 100 grams of the compound, so that means we have this many grams of phosphorus. Because you see, this ratio is the same no matter how much of the compound we actually have. Anyway, after we've done that, next step, real easy. Just take these grams, divide by their molar masses, and convert to moles. So 43.643 grams of phosphorus. The molar mass of phosphorus is 30.974 grams per mole. And that gives us this many moles of phosphorus. That many grams of oxygen divided by its molar mass gives us this many moles of oxygen. Now, the next step is we take whichever of those elements we ended up with the least number of moles of and divide it into the moles of all the other elements. Now in this case, there's only two elements, oxygen and phosphorus, but if there were more, if the smallest number of moles was phosphorus, we divide it into the moles of all of the elements, other elements in the compound. So when we do that for our numbers, we get 2.49998 moles of oxygen per 1 mole of phosphorus. Notice I put this on bottom. It's important because this is different, moles of oxygen and moles of phosphorus. So this is a ratio here. Now, we're going to look at this number. If this number is closer than 0.1 to a whole number, we just get to round to that whole number. But if it isn't, as is our case here, then we have to multiply our ratio here by some number over itself so as to make this number closer than 0.1 to a whole number. Here's a table that might help you. You can just put it in your calculator usually and figure it out. But here x represents everything to the left of the decimal. In our case, x was 2, right? 2.49998. So what you do is you look to the right of the decimal, and for us, 0.249998 is real close to 0.499998 is real close to 0.5. So we're just going to multiply by 2, and that gives us this. 2 over 2. Notice it's not just 2, it's 2 over 2, and we multiply 2 here and 2 here. It gives us 4.99997 moles of oxygen for every 2 moles of phosphorus. Now this number is closer than 0.1 to a whole number, so we get to round it, and it gives us 5 moles of oxygen for every 2 moles of phosphorus. Now we're pretty much done because that ratio there gives us the empirical formula. It says that there are 2 moles of phosphorus for every 5 moles of oxygen, and so our empirical formula is P2O5. That's our empirical formula.